Hi guys, it's Mrs. Glenn. Welcome to the 3-4 bell work and notes. So in 3-4 you learn about arithmetic sequences. So there's two different kinds. There's recursive formula and there's the explicit formula. So recursive formula is when you're trying to find a sequence so that you can predict what the numbers will come. An explicit formula is actually finding a specific number, say if we think of a sequence of numbers trying to find like the 100th number in that sequence, you're going to use the explicit formula. So go ahead and pause this video and work on 10, 11, and 12 for your bell work. All right, so just to let you know a little bit about the sequence formulas, A sub n, so that's how you say when you have an A and then a subset n, we call it A sub n, and n is the term you're looking for. So A sub 1 will be the first term because that 1 represents the first term in the sequence. And then 2 would represent the second term in the sequence, and so on, whatever the little number is below the A. And then n is the number of terms in the sequence, and d is the common difference. So both formulas use those same letters. Hold on a minute. Okay, I'm back. Both of them use the same letters. It's just how they use them within the formula is a little bit different. All right, so let's go over number 10. So number 10, the following sequence represents the amount of money Zara had in her savings account each week. So 2, 11, 20, 29, 38, 47, 56. Write a recursive and explicit formulas for her sequence. So first thing you're going to want to do is list out the variables that you're looking for. So A sub n, we don't know that answer. We're going to leave it in our formula. A sub 1 is the first number in the sequence, which is 2. And n is the term you're looking for. They did not specify what term we're looking for, so we just leave n in the answer. And d is the common difference. So what you got to do is you have to subtract the second number minus the first number. So that's 11 minus 2, and that's 9. And then you want to do one more, which is the third number minus the second number, just to make sure that it is actually an arithmetic sequence, because sometimes just a list of numbers aren't necessarily an arithmetic sequence, and we could find that out by doing it twice. So 20 minus 11, if that gives us the same number, then it is an arithmetic sequence. So we now know that the common difference, which just means subtracting, is 9. So now we're going to write a recursive formula and an explicit formula with those numbers. So our recursive formula is A sub 1 equals 2, and how you find what the first number is in the sequence, you just look in the sequence, that first number is 2. And then for the formula, you're going to do A sub n equals A sub n minus 1 plus 9. So if you look up here in the formula, we have d is what you're plugging in. Everything else is going to stay exactly the same. So that is the recursive formula. The explicit formula, however, is a little bit different because you do have to distribute. If you look here, we have a parentheses that you would have to distribute into the parentheses and then combine like terms to get your final answer. So that is simple, but it's just an extra step. So if we actually set that up, I'm going to show you. So just showing you where the 9 went, where the 2 went. So doing the explicit formula, we're going to set it up so that we can distribute that d into the problem. So we have n minus 1 times the common difference, which is 9. And if you distribute the 9 into the parentheses, you get 9n minus 9 and bring down the 2. And 2 minus 9 is negative 7. So your final answer is A sub n equals 9n minus 7. 9n, that's a tongue twister. All right, let's go on to number 11. Margaret's summer job pay is represented by the sequence 65, 73, 81, and 89. What is the explicit formula for the sequence? Again, I gave you the little chart over here on the right-hand side. The explicit formula is the second one down. So first thing you got to do is find the A sub 1, the n, and the d, and you notice that spells the word and, so you can remember what letters you have to find. So A sub 1 is the first number in the sequence, which is 65. N is the number you're looking for. It does not tell us any specific number in the sequence, so we keep n in the answer. And d is the common difference, and remember we find that by subtracting the second minus the first and the third minus the second. So we're going to go ahead and do that. The second number minus the first is 73 minus 65, which is 8. And then the third number minus the second is 81 minus 73, which is also 8. So 8 is our common difference. So now you plug those values into the correct formula and you'll get your answer. So we have a sub n equals a sub 1 plus n minus 1 times d. So that is the formula. But we now know a sub 1 is 65 and d is 8. So everything else stays the same. And now you can distribute that 8 into the parentheses, and you get 8n minus 8. Combine like terms, so 65 minus 8 is 57. Then look for the answer up above, A, B, C, or D, that has 8n plus 57, and that is C. So your answer for number 11 should have been C, and make sure for your bell work quiz, you have your work shown and the correct number for this bell work. So this is number 11. And also make sure you have the date. So today's date's a little bit different than normal. It's 10, 15, and 16, because normally we would have done this lesson in 2 days, but I'm going to be doing the video in 1. Okay, so going on to number 12. The following graph represents the number of seats in each row of the movie theater. Write an explicit formula to represent the number of seats in the nth row. How many seats are in the 12th row? All right, so we have to write an explicit formula. So you're going to look at the explicit one. That's the second one down. Again, you're going to find a sub 1, n, and d. So a sub 1 is the first number in the sequence. And if you look at the graph, you can see that the first number in the sequence is 50. That's where the first y value is. N is the term you're looking for, which is 12, because they tell you the 12th row. And d is the common difference. And we're going to do the subtracting, but we just have to look at the graph for the numbers. So we're going to subtract the second minus the first, so that's 55 minus 50, which is 5. And then subtract the third minus the second, which is 60 minus 55, and that's also 5. So your common difference is 5. Now we can take those three numbers and plug them into the explicit formula, and we have our answer. So instead of writing n for a sub n, I can write a sub 12, because that's what we're looking for, equals 50 plus n minus 1 times 5. So I'm going to distribute the 5 into the parentheses. Combine like terms, 50 minus 5 is 45. So our explicit formula is 45, or 5n plus 45. And then it says there are 105 seats in the 12th row. Well, how do you know that? So question mark. How did they know there's 105 seats? What you got to do is plug 12 into the function we just found. So we're going to replace n with 12, because we've already identified n up here as 12. So we could have done that earlier. I can't draw the box. There we go. So we're going to plug n in with 12 and then calculate. So 5 times 12 is 60. 60 plus 45 is 105. That means in the 12th row, if the trend continued, there will be 105 seats in that row. All right, so let's start 3-4. This is Explore and Reason. Make sure you put today's date. It's 10/15 and 10/16. So a fashion designer is designing a patterned fabric. There are 5 shaded squares in row 3. So if you're looking in row 3, you can count the blue squares. There's 5 of them. So they filled the table down below at row 3. There's 5. The total number of shaded squares up to and including row 3 is 9. So what they do is they're adding diagonally, and I'm going to show you how to do that. It's pretty simple once you know how to do it. So let's fill in the rest of the rows by counting them. So in row 2, there are 3 shaded areas or shaded squares. And then in row 4, there are 7. And in row 5, there's 9. So all you got to do to figure out what the numbers are is you just add diagonally. So 1 plus 3 is 4, so we put 4 down. And then 4 plus 5 is 9, and 9 plus 7 is 16, and 16 plus 9 is 25. So you just go diagonally and then down and put your answer. Diagonally and then down, put your answer. Diagonally down. So what number patterns do you see in the rows? Well, we see that as each row increases, it increases by 2 shaded squares. So the difference of the pattern squares is 2 as you go down through the rows. All right, so let's go to example number 1. Is the ordered list 26, 39, 52, 65, 78 an arithmetic sequence? So a sequence is an ordered list of numbers that often forms a pattern. Each number is a term of sequence In an arithmetic sequence, the difference between any two consecutive numbers, so right next to each other, is consistent with the common difference. So if we list our numbers down below, 26, 39, 52, 65, and 78, the difference going from one number to the next is adding 13 each time. So that makes it an arithmetic sequence. So the common difference is 13, and it's consistent throughout the entire sequence. So yes, it is an arithmetic sequence. Let's look at 1b. How are sequences related to functions? So you can think of a sequence as a function where the domain is the natural numbers and the range is the terms in the sequence. So your range is going to be the numbers you see in the sequence with the commas in between, and what you're plugging in, the n, that is going to be your domain. So whatever you plug into the formula, and the answer that you get essentially is a function. N is your x values and the sequence is your y values. So a sub 1, which just means the first number in the sequence, is 26. A sub 2, the second number in the sequence, is 39. And that's literally all it is, so yes, it is a function. All right, 1c, how do you represent sequences using subscript notation? So when you look at that in the middle, it says a sub 2 equals 39. You're going to say a sub 2. That's how you say it. You don't say a subset 2. You abbreviate to a sub 2. Is 39, and that's the second term in the sequence. So whenever you see that little number, that tells you where in the sequence they're referring to. So second place, third place, fourth place, wherever it is in the sequence. That little number will tell you what it is. All right, so do a try it. So I'm going to read the problem, and you're going to pause and try it on your own. So an n is the a sub n is the value of the nth term of the sequence, 26, 39, 52, 65, 78. Is the domain of the function continuous or discrete? So is what they're plugging into the function and getting the answers 26, 39, 52, 65, and 78, is that continuous or discrete? So if you remember from the beginning of topic 3, we talked about continuous and discrete. Continuous is the type of points that can make a line, which means that you could also plug in decimals. But discrete is just individual points that do not make a line because they do not have decimals that you can plug in. So can you plug decimals in to get those answers, or can you not? So if you can't, it would be discrete, and if you can use decimals, it would be continuous. So go ahead and hit pause and then come back and check your work. All right, so let's take a look. So the domain is discrete because the domain represents the number of terms, and it only can include natural numbers. So when you're plugging in the first term, the second term, the third term, and so on, we're not talking about the 1.5 number. We're talking about either 1, the first number, 2, the second number, 3, and so on. So these numbers that are above, if you were to list them out, this is number 1, this is the second number, this is the third number, the fourth number, and so on. So we do not have decimals for the numbers in the sequence. So discrete means individual points, not a continuous line. And so this is a domain that is discrete because the domain represents the number of terms and it only includes natural numbers. All right, so let's talk about a definition of recursive formula. So with arithmetic sequence, we have recursive formula and we have the explicit formula. So we're going to go over the recursive formula first. So in mathematics means to repeat a process over and over again. So recursive means that you're constantly using the same first number and then adding or subtracting something to it to get to the next number. So a recursive formula relates each term of the sequence to the previous term. So whatever the previous one did, then you have to multiply or add 3 to it. So if we said 1, 2, 3, 4, 5, that would just be adding 1 to the previous number. So you add 1 to 1 gets you to 2, you add 1 to 2 gives you to 3, you add 1 to 3 gets you to 4, and so on. So recursive means that it goes back and adds to the previous one for arithmetic sequence. So it's the same letters, a sub 1, n, and d, but for this equation, it's a sub n equals a sub n minus 1 plus d. So a recursive formula describes the pattern of a sequence and can be used to find the next term in the sequence. So explicit finds a specific term, recursive finds the next term. That's the difference between the two. All right, so let's do an example. Example number 2a. What is recursive formula for the height above the ground for the nth step of the pyramid shown? So whenever they say nth step, nth of anything, that means that we're going to leave n in the answer, and that makes sense because they just want the formula. So in order to use the formula, you have to have a variable in the equation. So we have to keep n in the equation in order to keep the formula or use the formula. So use the recursive formula. So a sub 1 is the first step, which is 26 centimeters tall, and we have that from the picture. And then a sub n equals a sub n minus 1 plus 26. So 26 is going to be your common difference because every step is going to be 26 centimeters tall. So anytime they go to the next step, it'll be plus 26, and then to the next step, plus 26, and so on. So that is your recursive formula. So everything is the same. The only thing we're changing is just adding a 26 because we do not know the step they want us to find. So then it says the formula a sub n equals a sub n minus 1 plus 26 gives the height above the ground of the nth step with a sub 1 equal 26. So now we could use that formula and say for the 15th step, how many centimeters is it from the ground? And we could plug 15 in and find what the answer is. All right, so use the recursive formula a sub n equals, hold on a minute. I'm still at school, guys, recording this, and they just had a really loud announcement. Anyway, example 2b, use the recursive formula a sub n equals a sub n minus 1 plus 26, where a sub 1 is 26, to find the height above the ground of the third step. So here we go. So we know the equation, a sub n minus 1 plus 26, but we want to find the third step. So we are plugging 3 into where the n is and finding that step. So we know that a sub 1 is 26, a sub 2 would be 26 plus 26, right? So the first step plus another 26, that would be 52. And then a sub 3 would be the third step. So if we step on the first step, which is the ground, and then we go up to the first step is 26 centimeters, the second step would be 52 centimeters from the ground, and then the third step is just adding another 26, which would give you 78. So the third step is 78 centimeters above the ground. So that is the recursive formula that's just going to tell you the previous. Recursive means we use the previous number in the sequence to get to the number we want to get to. So step number 1 is 26, step number 2 is 52, because we're adding 26 and 26, and then you add another 26 to 52, and you get 78. So 78 centimeters above the ground. All right, now let's take a look at a try it. So example number 2 for a try it, write a recursive formula to represent the total height of the nth stair above the ground if the height of each stair was 18 centimeters. So instead of 26, now it's 18. So take a look back at what we did for the example, for example number 2, and see how it's going to change if it's 18 centimeters instead of 26. And then go ahead and make the recursive formula. So the recursive formula is this one right here, and you're going to plug it in. Go ahead and pause and then come back and check your work after you're done. All right, so now let's take a look at what you should have for the recursive formula. So the recursive formula represents a new sequence, and remember it is just changing that common difference, the d at the end, to an 18, because that's what the difference between the steps are. So everything stays the same in the formula. The only thing you're changing is 18, because we do not know the step they want us to find, so we leave n in the answer. So let's see if you're right. If you got it right, go ahead and give me a smiley face on your notes for today. Put a smiley face if you got it right. All right, so let's take a look at the new formula, which is explicit formula. So explicit formula will actually get us to exactly whatever term in the sequence it is. An explicit formula is really useful when we're trying to find like the 100th term or the 202nd term, where you don't want to sit there and actually figure out the sequence, 202 times to find the 202nd term. So explicit formula just gets us that answer faster. So it's a little bit different. It's a sub n equals a sub 1 plus n minus 1 times d. So they put the d at the end instead of in the front, just so that the plus sign and the d don't mix together. It's kind of a little bit neater. So the a sub 1 represents the first number in the sequence, N represents the term or the question they're asking. So if they tell you to find the 10th term or the 10th number in the sequence, that's N. And D just stands for the common difference. So all you got to do is subtract and find the difference between each number in the sequence. And I'll show you an example of that. So remember, recursive used the previous number to find the next. Explicit we used when we want to find a term within the sequence that's way far away, so like 100th term or the 50th term or so on. All right, so an example, the cost of renting a bicycle is given in the table. How can you represent the rental cost using the explicit formula? So we can see that the rental cost is $26 for 1 day, $38 for 2, $50 for 3 days, and $62 for 4 days. So again, we're using the explicit formula. So we can see immediately that A sub 1 is 26. That's the first number in the sequence. The common difference is 12 because that's how it's increasing each time. And that's all we have to plug into the explicit formula. So we're going to take this formula right here and replace those letters that we just found with the numbers that we found. So replace A sub 1 with 26 and replace D with 12. And you'll notice that's what they did right here at this level. And then all you got to do is distribute your 12 into the problem. So 12 times n, let me draw that little arrow. 12 times n, it gives you 12n. And 12 times negative 1 gives you negative 12. And then we can combine like terms. So we have negative 12 and 26 that we can add together, which gives you 14. And then your final answer is A sub n equals 14 plus 12n. So I do want to tell you that sometimes that can be written as A sub n equals 12n plus 14. Is it right to do it any specific way? No, you can do it either way. Typically, the reason why they have it written this way is if the common difference is actually negative. So if the common difference was a negative number, it's proper to have it second. If it is positive, then it would be written first. So the formula has the A sub 1 written first. So if this A sub 1 was a negative number, we would want it to be at the end, and it just makes it look neater. To be honest, there's no real reason why it's written second. But anyway, the explicit formula A sub n equals 14 plus 12n gives the rental cost of n days. So this is the formula that you would use to calculate any number of days to see how much it's going to cost. All right, so 3b, what is the cost of renting a bicycle for 10 days? So they give you the formula, and they tell you that they want to know how much it's going to cost for 10 days. So this is your n, 10. So we're going to replace this n right here with a 10. So all you got to do is replace it with a 10 and calculate it. So 12 times 10 is 120. 120 plus 14 is 134. So it will cost $134 to rent a bike for 10 days. All right. Now let's do 3c. So how is it the explicit formula of an arithmetic sequence related to a linear function? So let me get back here. The formula A sub n equals 14 plus 12n shows the cost of A sub n is a function of the number of days n the bicycle is rented. So think of it like this. Your domain is the number of days that you're renting the bike, and your range is the cost for renting that bike for that number of days. So that is a linear function. You're plugging in the x values and you're getting a y output. So it is going to create a linear line on the graph here. So obviously you're not going to be renting the bike for half a day, so it will be a discrete line, but it will not be a continuous because we can't rent the bike for half a day. They never said that. So you can write this as a linear function f of x equals 12x plus 14, or as an equation of a slope-intercept of y equals 12x plus 14. The common difference is 12 corresponds to the slope of the graph. So every day it's the difference is $12 more each day. So it's going to go up 12 over 1. So if you look at the graph, it goes up 12 over 1, up 12 over 1, up 12 over 1, up 12 over 1, and so on. And that's how an arithmetic sequence for the explicit formula is just like a linear function. All right, so example number 3, try it. So the cost of renting a bike is $28 for the first day, but then it's $2 every day after. So you have to pay up front a little bit more, and it's less if you keep it longer than 1 day. Write an explicit formula for the rental cost for n days. What is the cost of renting the bike for 8 days? So we got two parts here. We have to create the formula and then find out how much it's going to cost for 8 days. So the explicit formula for the rental cost is a sub n equals 26 plus 2n. So we know that that came from the explicit formula, so that means they had to distribute that common difference into the parentheses. So that's why the number 26 is a little different. So I'm going to show you how they got that answer. So again, we have to come up with our a sub 1, our n, and our d. Remember a and d. So a sub 1 is the first number in the sequence, so that's $28. N is going to be what we're looking for. We don't know that yet, and the common difference is $2 every day. So it does tell us in the 8 from the problem, so we can put 8 in there, but for our formula, remember, we need to leave n in the answer. So if we rewrite this with the formula, we're going to replace a sub 1 with 28, and we replace d with 2. Then you're going to distribute your 2 into the parentheses, giving you 2n minus 2. Then we can add 28 and negative 2 together, giving us that 26. So that's where the 26 plus 2n came from. And then to find out how much it's going to cost for 8 days, they already told you it's $42, but I'm just going to show you how they got it. So you replace n with 8. So I changed it to a purple 8 there. 2 times 8 is 16, and 16 plus 26 is your $42. So just working backwards, that's how they got the answer. I know 26 doesn't look right because it's 28 in the problem, but remember, you have to distribute that 2 into the parentheses, and that's where the 26 ends up being when you combine 28 and negative 2. All right, so let's take a look at another problem. Example number 4, write an explicit formula for the height above the ground of the nth step of the stairs shown as a sub n equals a sub n minus 1 plus 4, with a sub 1 being 7. So the first height of the step is 7 inches tall. You can look at the picture. And it says, what is the explicit formula finds the height above the ground for the nth step? So we have to write an explicit formula coming from the recursive formula. So it's a little bit different. So we're starting out with the recursive formula, and we're having to write an explicit formula. So the recursive formula they gave us right here in the problem was a sub n equals a sub n minus 1 plus 4, where a sub 1 is equal to 7. So that's what they stated right here. They're just stating what they were given in the problem. And we need to now convert it back to an explicit formula. So we know that the a sub 1 was 7. We know that d was 4. So you literally take the explicit formula and replace a sub 1 with 7 and replace d with 4. And you have your answer. That's it. Not very hard, is it? So the explicit formula a sub n equals 7 plus n minus 1 times 4 can be used to find the height above the ground for any step, or for the nth step is what they say. And that's how you would do it. So working your way from the recursive to the explicit is pretty easy because the letters in the recursive are the same as the letters in explicit. You don't have to do any kind of distributing. But going the other way, going from explicit to recursive, is a little difficult. So I will show you how to do that. So write an explicit formula for the arithmetic sequence. So we're starting out with recursive, and we have to go as an explicit. So the explicit formula is a sub n equals 13 minus 3n. And you're probably wondering, how did they get that? Well, all you got to do is identify your a and your n and your d. So a sub 1, the n, and the d. A sub 1 is the first number in the sequence. They gave that to you. It's right here, 10. And then n, they didn't tell you, so we're going to leave that in our answer. And d is the common difference. So if you remember from the recursive formula right here, d is the number that's at the end right here, but it's plus d. So if that was negative 3, what would our common difference be? It actually would be a negative 3. In order to make that a negative from the formula, because the formula is positive, it would have to be a negative 3. So now that we have those two numbers, we can plug it in to the explicit formula and solve by distributing and get the answer. So we're going to write the explicit formula out. So a sub n equals 10 plus n minus 1 times that negative 3. Then you're going to distribute the negative 3 into the parentheses. That gives you negative 3n plus 3. Then you're going to add 3 and 10 together, and you get your 13. And 13 minus 3n would be your answer for the a sub n explicit formula. For b, we have a sub n equals a sub n minus 1 plus 2.4, where a sub 1 equals negative 1. So you're going to do the same thing. I want you to pause the video. Go ahead and try B on your own. So look at my A and do the same thing. Find your a sub 1, your n, and your d, and plug it in and then distribute. So go ahead and do this on your own. Pause the video and then come back and check your work. All right, welcome back. I know some of you did not pause the video. Naughty, naughty. All right, so anyway, we're going to find the a sub 1, the n, and the d. So a sub 1 for this problem is negative 1, because they gave it to you right here in the problem. A sub 1 is negative 1. You didn't have to go and find it. And then n, we don't know. We're leaving it in the answer. D is the common difference. So again, that's going to be the number that it's at the end right here. So we have positive 2.4, so that will be 2.4. So all you gotta do is plug in your negative 1 and the 2.4 into the problem and distribute. So we're gonna rewrite the explicit formula. So we got negative 1 plus n minus 1 times 2.4. So you're gonna distribute the 2.4 in, and you get 2.4n minus 2.4. And then you can add negative 1 and negative 2.4 together. So negative 1 minus 2.4 gives us negative 3.4, and then just drop down the 2.4n. And that is your answer. So that's why the answer from here was the same answer that I got right here. So you can work your way backwards, just identify the a sub 1, n, and d, and then distribute. All right, now moving to example 5. And if you didn't notice, up here on the date, we are actually doing 2 days and 1 on this video. So that's why the video seems a little bit longer than normal. So example number 5, the explicit formula for an arithmetic sequence is a sub n equals 1 plus 1/2 n. What is the recursive formula for the sequence? So we got to work backwards. So we're going to identify the common difference. We know that the common difference is multiplied with n, so that 1/2 is actually the common difference. Then find the first term in the sequence. Well, we know that a sub 1 is what they put in the front. So a sub 1 was in the front, so we have 1 plus 1/2. And if we're trying to find the first number in the sequence, all we have to do is plug 1 into our equation that they gave us, and it'll tell us what a sub 1 is. So remember, a sub 1 is just the first number in the sequence when they list the numbers with commas in between. So if we know that we're trying to find the first number, we just plug 1 into n, and it'll give us what that first number is. So at the bottom, step 2, they plugged 1 in. 1/2 times 1 is 1/2, and 1/2 plus 1 is 1 and 1/2. And so 1 and 1/2 as a mixed number turns into 3 over 2, and that makes sense because if you divide 3 by 2 into 3, you'll get 1.5. So 1.5 is the same as 1.5. So I'm going to erase that really quick because I got some other work that's going to be on the right here. So it says step 2 and now step 3. So we have the a sub 1. We have the common difference. So a sub 1 is 3/2. We have the n is what we do not know, so that's not applicable. And our d, the common difference, is now going to be 1/2. And we've found that here for the d, and a sub 1 was right there. So now all I got to do is substitute 1/2 in for d, and a sub 1, a sub 1 is just listed as what a sub 1 is. So you don't have to plug a sub 1 in for a recursive formula, you just have to list what it is. So a sub 1 equals 3/2, and the recursive formula is a sub n equals a sub n minus 1 plus 1/2. So you take 1/2, plug it into d, and you take 3/2 we found for a sub 1, and you just list what the a sub 1 is. And that's only for a recursive formula, because we don't use a sub 1 in the recursive formula, but to know where it's starting, we need to know what a sub 1 was. So you don't put it in the formula, you just list it separately. All right, now we're going to do some try-its. So write the recursive formula for each explicit formula. So you're going to go backwards. So starting with the explicit, you're going to go back to the recursive. So we know that we can identify a couple things. For A, I'm going to do A with you, and then you're going to do B on your own. So the recursive formula is a sub n equals a sub n minus 1 plus 3, and a sub 1 equals 11. Well, how do they know that? So first of all, you can find a sub 1, n, and d. So a sub 1 is just when you plug 1 into the formula, you can solve. So we would plug 1 into here, and we would get 11. So that's a sub 1. And then for common difference, we can look at the problem and say, well, how did they get 3n? So what number times n gives us 3n? That's what we're looking at right here. What number times n give us 3n? Because remember, when you're distributing that number that's right here in this spot, you're multiplying it by n, which gives you the answer. So that number obviously had to be 3 in order to be distributed and equal 3n right here. So it has to be 3, so the common difference is 3. And then your a sub 1, like I said before, is just adding 1 into the problem and getting the answer, which is 11. So if we wrote 8 plus 3 times 1, that would equal 11. All right, so we rewrite the formula into the recursive formula, so a sub n minus 1, and it needs to be plus d, and we just found that d is equal to 3, and that is your answer. And then we just list a sub 1 separately, which is 11. So your two answers when you're trying to write recursive need to be the formula and what a sub 1 is equal to. So go ahead and pause the video and try to do it on the right-hand side. Again, you need to identify a sub 1, n, and d. And I gave you the little clues of how to find that with the writing in blue. And go ahead and pause it and come back and check your work after you're done. All right, welcome back. So B is a sub n, they're saying equals 12 minus 5n, turns into a sub n equals n minus 1, minus 5, a sub 1 equals 7. So how did they get that answer? I just realized I left the answer up for when I asked you to pause. Oh well, so you should have shown your work. But either way, so we're going to find a sub 1, n, and d. So we're going to find d by saying what number times n would give us 5n right here, this negative 5n. So what number times n would give us 5n? Well, that would have to be 5, right? And it's not negative 5, actually, it's positive 5. So let me get rid of that. That is wrong. Wrong-o, wrong-o. All right, so it's 5, and then plug 1 into the equation to solve for the a sub 1. So let's see if I end up getting the wrong answer there. Yep, so this should be positive 5. So that is your first, actually, sorry, minus 5 because that's part of the formula. And no, I was right. It is negative 5. Mrs. Glenn, what are you doing? Let me change that. So go back. Doot, doot. It is negative 5. Let me get back in there. There we go. All right, so a sub n minus 1 minus 5, and if we plug 7 into the problem right here, it's going to tell us, I mean, sorry, not plug 7. Plug 1 into the problem, it will tell us what a sub 1 is. So if we plug 1 into this part right here, you'd have 12 minus 5 times 1 will give us what a sub 1 equals. So 5 minus 1, or 5 times 1 is 5. So 12 minus 5 equals a sub 1, which means 7 equals a sub 1. So your answer is two parts, the formula and what a sub 1 equals. So you should have that work shown on your paper when you're trying to do the problem. So check your work and see if you were right. Go back in the video if you didn't get it right and see what you did wrong. And then the last thing we're going to do here is the concept summary. So again, recursive formula, remember, uses the previous term to find the next one, and that's a sub n equals a sub n minus 1 plus d. And your explicit formula finds a specific number in the sequence, and that's found by using a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 is the first number in the sequence, n is the number you're looking for in the sequence, and d is the common difference. So common difference just means how is the numbers changing in the sequence. So is it adding 2 each time? Is it adding 10 each time? Or is it subtracting? Whatever it might be. So looking at the bottom, you can see the sequence 1, 7, 13, 19, and 25. So how does 1 get to 7, 13, 19, and 25? It's just adding 6 each time. So that is your common difference. And then the first number in the sequence is 1, so that is your a sub 1. And then you can plug those numbers into the sequence and calculate whatever you need to find whatever term. So if you're looking at the explicit formula, again, we're going to use the same numbers. We plug 1 into the front because that's where a sub 1 goes. And your common difference goes on the outside of the parentheses. And then you can distribute the 6 in and get your answer and find that the 15th term of that sequence would be 85. So that's why explicit formula is really easy to use, because all you got to do is plug in the known values and it will tell you what that number is in the sequence. I do want to say really quick at the very end here, if you are needing help on any lesson, I don't know if you know this, but there are virtual nerd videos on every lesson. They are between step 2 and 3, I believe. If you look in the lesson right before Math Excel or right after it, it'll say virtual nerd. And usually there's 2 or 3 videos depending on how many concepts are taught in the lesson. And all you got to do is click on it and watch it. It's really short and it re-explains the concept to you. So if you're struggling understanding it from the class, then I would definitely go to the virtual nerd videos and watch that. And they are on every lesson from topic 1 all the way to the end of the year. So please utilize those to help you if you need help in anything on the concepts. And that is the end of the video. I hope you have a great day, and I will see you tomorrow. Bye-bye. Go Seahawks. Woo!